Okay, so here's how you do this first problem. So this problem is a little bit trickier because we got to remember some stuff from geometry and Algebra 1 plus some of our newer stuff. So when I have a problem like this, what I would like to do when I'm simplifying is we really got to break apart this square root into the things that we can and can't do. So I'm going to break this down to 7 minus the square root of -1 and the square root of 24. And the reason I did that is I have no clue what the square root of a negative number is. So we're going to break it off to the side. So the square root of a negative number is going to give us some I. Now I also don't know what the square root of 24 is, and I would be tempted to put a. But the reason I am not going to put a is because sometimes you can break down these into square roots that you know. And a square root that I know from this is I know the square root of 4 and this times the square root of 6 equals 24. And the square root that I know is I know the square root of 4. The square root of 4 is 2. So this would give me 2i. And the square root of 6 is just the square root of 6. So this would be my final answer, or D. Okay? So when you're doing this, be very, very careful. Like, of course, the square root of -24, like I can't do that, so I'm going to have to take out the square root of that negative number. That will be my I. And then if you can break this down further, you should try into square roots that you know. And the square roots that we know are the nice square roots, such as, like if I made a quick list, square root of 4, square root of 9, square root of 16. Like those are nice square roots because that's 2, that's 3, that's 4. So you just have to try to find a nice square root inside of there. Let's try the next problem. Okay, so for this problem we just need to solve, and this should be very easy to do because I'm just going to add 8 to both sides. I'm going to get 2k squared equals 8. I'm then going to divide by 2, get k squared equals 4. Take the square root, I'm going to get k equals plus or minus 2, which would be b. The common mistake for people to do is to forget this plus or minus. So when you take the square root of something, you need to have 2 answers. The other thing that we know about that is, oh, it's to the second power. We have to have 2 answers at the end. Let's try the next one. So this is a systems of equations. We would want to use elimination because these things are stacked. Unfortunately, right now, we can't eliminate because they are not the same things, because if you added straight down, nothing would cancel out. So what we're going to do to fix that is we're going to times this top by 3 so that these would become the same numbers. So that's going to be 6x plus 3y equals -9. And this would be -6x minus 3y equals -2. And now when I add straight down, this will cancel, which is going to leave this side as 0, equals -11. And we look at that, because 0 equals -11, that is never true, so this would be a no solution problem. Let's try the next problem. So for this problem, what we would want to do is we would want to use elimination again, because these things are stacked. The problem is nothing will cancel out if you add. So what we are going to do is we are going to times this bottom equation by 2. And we're going to want to times this bottom equation by 2 because that will make this -10 and this 5 match. So that's going to give me -8x minus 10y equals 24 over 12x plus 10y equals 4. Then we're going to add them together, which is going to give me 4x. This will cancel out. This will give me 28. And then we'll divide these things by 4, and I'll get x is 7. Now if you stop here, that is not going to be good for the test because you are going to want to continue and find your y value. So to find your y value, you need to take your x and plug it into one of the equations. I am going to plug it into this equation right here because it has no negatives and it's the smallest numbers. So it'll be 6 times 7 plus 5y equals 2. This would give me 42 plus 5y equals 2. I'd minus 42 from both sides. This would give me 5y equals negative 40. And then I would divide both these things by 5, giving me y is equal to negative 8. So my answers would be 7 and negative 8 for y. Let's try the next problem. Okay, so we need to find the median for this data set. To find the median first for a data set, what you want to do is put the numbers in order. So this would be 3, 3, 3, 8, 7, 8, 9, 9. Let's make sure I did this right. So I have 1, 2, 3, 4, 5, 6, 7 numbers here, and I have 1, 2, 3, 4, 5, 6, 7 numbers here. And we're going to find the middle number. So the middle number would just be 7. So that's my median or my middle number. Let's try the next problem. Okay, so they want me to write this equation right here in vertex form. And so if I have to write this equation in vertex form, what I need to do is I need to find the x and the y values that I could have for these things. So to find the x and the y values, what I'm going to do is I'm going to find an x value of a vertex, you use the equation negative b over 2a. So to do that, that would be 6, because that's my b term, and I want to make it negative, so if it's already negative, it becomes positive, over 2 times a, which is 3. So that's going to be 6 over 6, which gives you 1. And if you look through, there's only one choice that has your x being 1, which is this one. Now, if you want to double check and make sure we got the y value correct, you're going to take that 1 and plug it in here. If you did that, you'd get 3 times 1 squared minus 6 times 1 plus 12, which this would give you 3 minus 6 plus 12, which would be negative 3 plus 12, which of course is our 9 as our answer. So B is the correct answer. Let's try the next one. Okay, so this is the same type of problem. Again, we need to put this into vertex form. So to put this thing into vertex form, we need to find our x value and our y value. To find your x value, you're going to do negative b over 2a, and to find your y value, you're going to plug that in. So negative b in this case would be negative 36 over 2a. Well, 2a would become 4, because 2 times 2 is 4. That would give you negative 9. Then we're going to use that negative 9 and plug it into our equation here. So when you do that, well, there's only one answer that would work, which would be this one. And you might go, why is it positive 9? Well, it's positive 9 because it's always opposite inside here. But if you did plug this in, you should get positive 8 as your y value. Let's try the next problem. This is a really nice problem to get, and it should be easy to solve. So what we would want to do first is we would want to divide both sides by 5 to get the x squared by itself. And once you have the x squared by yourself, you're going to get this to be 2. You will take the square root of both sides, and you're going to get x equals plus or minus the square root of 2. And again, the most common mistakes here is to not put both answers. So it could be either these two, and that's a very common wrong answer. So just be careful when you're solving these things. Okay, so let's multiply and simplify this thing. Now the nice part about this is it's actually pretty easy to multiply these together, because you're going to get 2 minus 7i times 2 plus 7i, and then we're just going to distribute. So that's going to give us 4 plus 14i minus 14i minus 49i squared. And what you should notice about this is the 14s will then cancel out because they're the same. So you're going to get 4 minus 49i squared. And so at this point, what this will give us is a lot of people are going to be tempted to pick A right now. And you should not be tempted because I squared is a number that you actually know. Because I squared is, well, I equals the square root of -1. So if you square that, these things cancel, and you're just left with -1. So really, this is 4 minus 49 times -1, which that would be a negative times a negative is a positive, so 4 plus 49, or the nice simple answer of 53, which is D. Let's try the next problem. This is a lot like an earlier problem. Now, a common mistake that people want to do is they want to just put in 98 into their calculator and take the square root of it. And they go, oh, look, it's 9.9. But as you can see, there's a lot of extra numbers. So when we're simplifying, we do have to keep it the same unless they say we can round it, which we can't. And then you could just add these things together. So it's kind of, again, it's a misleading answer, but you do not want to pick it. What we're going to do is we're going to actually figure out what square roots we can break this into. And the square roots that we can break 98 into would be the square root of 49 and the square root of 2. Because 49 times 2 gives you 48, and we know what the square root of 49 is. The square root of 49 is 7. And this would be the correct answer. Let's try the next one. The rational roots theorem states that if this is divisible by any of the numbers or any of the factors, then you will get a remainder of 0. And so if you're looking at this and you're trying to decide what would make this thing a factor, well, if you think about how division works, you don't really worry about any of these other numbers except for this final number. So if this final number can be divided, then the rest should. So when you're looking at the answers to this, it'd be anything that can divide 8, which would be 2, 4, and 8, and 1, and the plus or minus would work for that. And normally it is that easy. However, because we have a number that is in front of the first term, it does affect your division because that first number kind of has an effect on all the other ones when it carries down for some of your synthetics and different things. So you also get any number of these divided by 2. Well, 2 divided by 2 we already have, which is 1. 4 divided by 2 we already have. Or 4 divided by 2 is 2, which we already have. 8 divided by 2 is 4, which we already have. But the one we're missing is 1 divided by 2. So you could also have plus or minus a half, which this would be then the correct answer choice. So again, for the rational root theorem, it's whatever divides this last number, and then every number that is divided by this front number from here. So those are your answers. Okay, let's try the next. Okay, so for this last problem, it's actually pretty easy. When you read this, we want to find where is the graph positive. So for what domains is the graph positive? And so we just have to find where the graph is positive. Well, that would be, well, let's choose a different color. The purple kind of blends in a little bit, so let's choose a bright green. So right here, the graph is positive, and right here, the graph is positive. And now you're just going to think about how to say this. Well, where does this graph start at? Well, it starts at negative infinity, and it stops here at -5. So the only one that has that is A, so A is going to be the right choice, but then we'll see this other one. Oh, look, this one starts at 2 and ends at 7. Yep, so that is why the correct choice is A. So when you're doing this, just kind of see where the graph is positive. You always look at the x values. Don't look at the y values because, again, the y values kind of do whatever, and you don't worry about them. So start and end at the x's. If you get stuck with anything, please let me know, and I'll try to help you through it.